All right, so now we're going to work on matrices and using matrices to help us solve simultaneous equations like we've been doing. And to start off, we're just going to I'll just introduce you to what a matrix is in mathematics. And so here are several examples of matrices. So we've got just the number 2. We've got a row of numbers. They use these all the time in computer science. All of your pictures are stored as a matrices of numbers, usually in the RGB system. And so the uses are just everywhere. But in this case, we'll keep it simple. And so that 2, so when you do a matrix, so if you say you have A, B, C, D, E, F, H, I, J, and we just have a set of numbers, to number it off here, this is the rows here. These are called rows, and these are called columns. Going down, so columns. And so what we're after is, in this case, we label our rows first and our columns second. So it's always rows by columns. And so, this particular one would be a 3 by 3 matrix because I got 3 going down and 3 going right. So if you just have this one number inside of a matrix, that is a 1 by 1 matrix for A. B, you only have one row, but you have 1, 2, 3, 4 columns. So that's a 1 by 4. C is kind of an easy one. That's a 2 by 2. And D, now you probably got it by now, you have 3 rows and 2 columns. So this is a 3 by 2 matrix. And so that's just how we number them and label them. And then you can also, if you want to know where something is labeled, like this number 4, for instance, that would be in the 3rd row and the 2nd column, whereas this number 7 would be in the 3rd row, 1st column. So you might have A with a little subscript of 3, 1. That would mean 7 if our matrix was A. So if we called this matrix A, A31 would be 7. Over here, A22, if we called this whole matrix A, A22 would be E, because it's 2 down, 2 to the right. A23 would be F. And so, they subscript that little number at the bottom. And so that's just some general things about matrices and how we can get to each individual. So you could think if you're a computer scientist and you wanted to just get at one pixel in that screen and change it, or a group of pixels, now we have a systemized way of getting to them. And it's a little different depending on which language you use in computer science, but this is the mathematics behind it. All right, so let's start using these things. So what we can do is we can leverage matrices to help us come up with solutions to systems. And that's how we'll use it. We won't do anything fun like making computer vision programs, but that's something you could do. It's a pretty fun activity. But we'll keep it on the simple side, or simpler side. So in this case, notice we basically just take the variables out and we create a matrix out of this thing. So this thing is a 3 by 4 matrix. And we go ahead and put these dots here just to kind of hold that equal sign, those 3 dots in that case. But we eliminate all the variables so that we can just look at this in terms of of just the numbers. And what we can do is we can eliminate these numbers on the, make these zeros. So we can have this thing, it's called the identity matrix, but if you had a 3 by 3, you would have all ones down the diagonal and zeros everywhere else. So, you know, so that's our goal for this front half, is to get that into what's called the identity matrix. And we're only going to do half of it, and then use back substitution to solve the rest of them. But you can get the identity matrix with it. So then the next thing we do is we're going to look at this. I'm going to leave this top row alone, and I want to make it 0 here. So I'm going to take the top row, row 1, and just add it to row 2 to give me another row 2. So that's how we list that out. So we're going to add row 1 and row 2, because if I add 1 and -1 here, I get a 0. So I'm going to leave the rest of my stuff alone. I'm going to leave my 1, -2, 3, and 9 alone. In fact, I'm going to take, just to save time, I'm going to take these 3 dots out too, because I can kind of keep track of it without the 3 dots. And I'm going to add R1 and R2 now in my head. So 1 plus -1 is 0. -2 plus 3 is 1. 3 plus 0 is 3. And 9 plus -4 is 5. And then I'm going to, and then there we go. And I'm not going to mess with the bottom row yet, because I want to, at the same time, and I'm going to do it in a different color here. So I did that for row 2. Now for row 3, I want to do something similar. Well, notice we have a 2 here and a 1 here. So if you take the top one by -2, so if you take -2 times R1 and add that to R3, we'll get a new R3. So I'll go ahead and do that. And so if you do that, and I'm going to show just a little bit of work here. I'm going to put it on the top. So I'm going to erase some of this stuff here. And so I'm going to multiply this thing by -2, this top row. So you'd have -2. I'm going to have +4. I'm going to have -6. And I'm going to have -18. And now we're going to add these two together to come up with our third row. Well, -2 plus 2 is 0. 4 plus -5 is -1. -6 plus 5 is -1. And -18 and 17 is -1. And so that helped us get 2 of our zeros for our identity matrix. So we've got those 2 zeros locked away. So now I'm going to get a 0 right here in that spot. I'm going to switch colors again. So we want a 0 there. And we want a new, so we're going to create a new matrix. And if you notice, if you just add R2 and R3 together, that would eliminate that. So here we go. We're going to go ahead and do that. I'm going to take R2 plus R3, and that will replace our R3. And so you do that. We're going to leave all the rest the same for now. We'd have 1, -2, 3, and 9. We've got 0, 1, 3, and 5. And now I'm going to go ahead and add that. And so you'd have 0, because 0 plus 0 is 0. 1 plus -1 is 0. 3 plus -1 is 2. 5 plus -1 is 4. All right, and we want a diagonal of 1s. We want a diagonal of 1. So 1, 1, we need a 1 here. Well, if you notice, if you look at this row, again, I should change colors. If we look at this third row, all we have to do is divide it by 2. So we're going to take R3 times a half, and we'll get a new R3, a new row 3. So row 3 times a half gives us a new row 3. So now my matrix looks like this. Everything else stays the same. 0, 1, 3, 5. But now if I take 1/2 times row 3, you get 0, because a half times 0 is 0, 0, and then 1, and then 2. And what that tells us is that z equals 2. We know one of our answers now because it's on the bottom here. So this 1 in the z location, this is your x's, this is your y's, this is your z's. Now we're going back to the variables, and this is saying that we can simplify this down to z equals 2. And it's the same as elimination, if you've ever done that. And so at this point, now you can just backtrack and turn this back into equations. And I'm going to move things around so we got more room. So we can leverage our bring our equations back. So our top equation now is x minus 2y plus 3z equals 9. It did not change. Our middle equation is y plus 3z equals 5. And our bottom equation is z equals 2. And again, you can just use back substitution to fill in the rest. So now z, we can plug a 2 right there. And so we know y plus 3 times 2 equals 5. So y plus 6 equals 5. You minus the 6 over, and y equals -1. So now we've got 2 of our answers. Y equals -1, z equals 2. And so what we can do after that is use back substitution again into this top equation here. And now you have x minus 2 times -1 plus 3 times 2, because that's z equals 9. And so you'd have x plus 2 minus 6 equals 9. You should double check your signs. Make sure you don't have any sign errors. Every once in a while I'll pick one of those up. And so you'd have x minus 4 equals 9. You add the 4 and you got 13. X is 13. And hilarious, I just found my mistake. I'm like, 13 can't be 13. So that's wrong. And I was checking my signs and I made a huge sign error, and you'll do the same. So notice here that should have been a +6. I don't know where the -6 came from. You might have been screaming at the top of your lungs, what are you doing? So 6 plus 2, that should not be a -4, that should be a +8. Then you subtract 8, and you get 1. So x is 1. And so there's some going back and double checking your work, making sure it's right. And so I've got an error there, and those happen. So x equals 1. And so there's my 3 answers. So we know these planes would meet at 1, -1, and 2. Okay, so that one's a fairly difficult one, but let's take a look at the next one. So this one's kind of crazy. And what we'll have to do in this case is, again, let's set up a set of matrices. So if you put this into matrix form, it'd be 0, 1, 1, -2, and then the dots, and then -3. But you could leave those dots out. So that's your top row. Your next row would be 1, 2, -1, 0, and 2. Okay. Your next row would be 2, 4, 1, -3, and -2. And then you'd have 1, -4, -7, -1, and then -19. And again, that's just so there you have a 4 by 5 matrix there. And so what we'll do is we want a 1 in the upper left corner. So I'm just going to swap these two out. I'm gonna let row 1 equal row 2, and I'm going to let row 2 equal row 1. So I'm just going to flip-flop the order of this thing. And typically I do that before I even started the problem. But so what we have now is we have 1, 2, -1, 0, 2, and I'm going to take those dots out. So I don't want to waste my time putting those in. 0, 1, 1, -2, -3. Okay, just make sure I got those right. Everything else I'm going to leave the same. So 2, 4, 1, -3, -2, and 1, -4, -7, -1, -19. And so what we want to do, so we've already got the first one done. We've got a 0 here, and we've got 2 of our 1s in good shape there, moving across by just making that one swap. So now I'm going to multiply this top equation by -2 and add it to row 3. So -2 times row 1 plus row 3 is going to give me a new row 3. And so you do that, and I'm just going to write these up here. So -2, -4, 2, 0, -4. Now I'm going to add those two together. I'm going to leave my top alone. So 1, 2, -1, 0, 2. That stays. The second row also stays. 0, 1, 1, -2, -3. But my third row now, we're going to add these together. So that would be -2 plus 2 is 0. -4 plus 4 is 0. Well, that's nice. 2 plus 1 is 3. 0 minus 3 is -3. And that's a -4 plus 2. Or say -4 and minus 2 is -6. So that's a nice one because we eliminated 2. So we got 2 zeros there. Okay, and then now we'll look at this third row, and I'm going to change colors again. So we're going to look at, or not the third row, the fourth row. And notice we got a 1 there. So we would need to multiply by a -1 on the top. So to get this row, you've got to take row 1 and change the signs and add it to row 4 to get a new row 4. And so this would be, and I'm just going to change it here, negative, negative, positive, 0 doesn't matter, -2. And let's add down. So you'd have -1 and positive 1 is 0. -2, -4 is -6. 1 minus 7 is -6. 1 minus 7, yep. 0 minus 1 is -1, and -2 and -19 is -21. Just double checking my signs because it's easy to screw them up. All right, I've got a couple things. This one's pretty much done. Row 3, we'd have to divide everything by 3, and we'd have our 1 in that diagonal that we need. And here we've got to eliminate that -6. So I'm going to use the row right above to do that. So for this next one, I'm going to do two things. I'm going to change row 3. I'm going to change row 3 by taking 1/3 times row 3. And I'm going to change row 4 by taking -6 times row 2 and adding it to row 4. So I'm going to do both of those things. And so my top row, I'm going to leave the same. So it is 1, 2, -1, 0, 2. That does not change. My second row does not change. It is 0, 1, 1, -2, -3. Now we are going to multiply it by a -6 here in a second, but for the matrix itself, it stays the same because we want a 1 there in that diagonal. And then my row 3, I'm going to multiply by a third, so that would be 0, 0, 1, -1, and 2, -2. So we'll multiply everything in there by 1/3. And then to get my last row, now we got to do the math to this thing. So we're going to take this by -6. And I always I'd kind of write it up above. So this would be 0. It doesn't change. That'd be -6. This would be -6. That'd be +12. And then that would be +18. So now I can add that to my row 4. So 0 and 0 is 0. -6 plus 6 is 0. -6 minus 6 is -12. 12 minus 1 is 11. And 18 and 21 negative is -3. It must be late at night. I see another mistake I made. That should have been a +6, not a -6, because we need the signs to be opposite. -6, so this should have been positive. This should have been positive. This would be negative. This would be negative. So that bottom row is going to change. Jeez. Must be late at night. So, typical mistakes that you're going to make. I would delete this and remake it, but I really don't think that's pertinent here. I think you need to see that even I've done this a bunch and I still screw them up once in a while. So you got to go. So you've already seen 2 mistakes in here. So you've got to be able to catch your own errors. So when things don't look right, that's kind of part of mathematics. It's like, what the heck's going on there? Something isn't quite right. So I could see something mentally not right. You picked it up probably sooner than I did. So now we got 6 and -6. So we got 0. You'd have 0. 6 and -6 would be another 0. So there's my third one. And then -12 and -1 is -13. And I'm going to check that. That's got my hackles rising. And -18 and -21, I was going to put an equal sign there, but negative, so 39. Oh no, that looks good. Ooh, that's good. So we've got our third row, and I noticed 39 is divisible by 13, so if I just take this bottom row by 13, by 1/13, negative, I get the ones I need. So now my new matrix is 1, 2, -1, 0, 2, 0, 1, 1, -2, -3, 0, 0, 1, -1, -2, and then we'd have 0, 0, 0, and 13 divided by 13, negative, is 1. And -39 divided by 13 is 3. And so we have one of our answers. We know W equals 3. Holy cow. So now you can back substitute that to find the rest of your answers. So this second equation, I'm going to go to purple here. This equation basically says 1z minus 1w equals -2. So you plug the 3 in for w, so z minus 3 equals -2. You add the 3 over, and z is, so now we know z is equal to 1. So we've got 2 of our answers. And then you plug those 2 in to the equation right here, our second equation, which would be y plus z minus 2w equals -3. And so you can plug that in then, put our same functions in here. So y instead of z, we got a 1. So y plus 1 minus 2 times 3 is -6 equals -3. That'd be -5 plus 3 is 2. So we know y is 2. And finally, the top equation, that is x plus 2y minus z equals 2. Because there's no 0 is w, so there is no w to plug in, which is kind of nice of them. So x plus 2 times y is 4, minus z is 1 equals 2. So x plus 3 equals 2, and x is -1. And we have all of our answers. And this is a fourth dimension, so here you go. If you've never worked in 4 dimensions before, now you have. So here is my 4 dimensions. And I'm just going to go with the order they gave them to us instead of alphabetical. Whoops. Instead of W there, we need our numbers. Oops, not a ruler, that one. Okay, so -1 for x, 2 is y, z is 1, and w is 3. And so in a fourth dimensional space, how you look at that geometrically would be pretty tough for us to visualize. The point -1, 2, 1, and 3 is where all those planes would converge. So if you're still with me, congratulations, and hope it helped. I'll see you next time.